Good morning everyone, welcome to the EduSat network. Today's topic of discussion is measures of association. We are going to look at the correlation between series and data. This is part of a lecture series on media research that we have been running for quite some time now, and these lectures have been spearheaded by Dr. Devesh Kishore. Dr. Devesh Kishore is a well-known name in the field of journalism and mass communication, and he is kind enough to be with us here today. It's a privilege to have you here, sir. Welcome. And with this, I request you to begin the lecture.
Thank you very much. Today, we will be discussing about measures of association. As a student of research, we all know that the data which we collect, we try to find out from this data dispersion from the averages or any association between the variables. So, when we say measures of association, it means we are trying to find out how these variables are associated. In other words, how they are related. And other word which is also used for measure of association is correlation. So, therefore, let us understand the meaning of measures of association. You as a research scholar, when you have a data available with you, you will find that there may or may not be any association between two phenomena. Let us take example, if there is, you take one variable as an age and second variable if you take an education, and if you try to find out as the age increases, the education level increases. Now, that is a relationship. So, we are interested to measure this type of relationship or association between the two series or two variables. Now, that in that case we call it as correlation. Now, correlation or relationship between the data can be of different types. One is called positive or direct correlation. What does direct correlation means? Means both the phenomena, the variables are changing in the same direction. Same direction means, suppose age is increasing, education level is also increasing. It means they are going in the same direction. So, that will be called positive correlation. If one increases and second decreases, that means one area will be increasing, age is increasing and level of literacy is going down, then it will be negative correlation. So, there can be two situations, positive, negative correlations. Positive correlation perfect is +1. If you get +1, it means it is a perfect positive correlation between the two set of variables or series. If it is -1, that is perfect negative correlation between the two variables or series. So, the correlation will never be more than 1 if it is positive +1, not more than -1 if it is negative, because that is a perfect situation when it is. Third type of correlation is curvilinear correlation. Now, curvilinear correlation is when the ratio of changes in two variables varies in some parts of the series. Let us say if we take the example of the same example of age and education level, and we find that when the age is increasing, but when we see the groups, sometime it goes down, sometime it goes up. It means there are curves, there neither they are perfect, neither they are negative. In case of perfect positive correlation, both the variables are going in the same direction. That means age is increasing and literacy level is increasing. Negative was when one is increasing and second is decreasing, or if first is increasing, second is decreasing, whatever association, that will be perfect negative correlation. And curvilinear correlation is when two variables like age and education level or literacy level are changing, of course, but their ratio of change in different groups has different type of ratio. That is called curvilinear correlation. This can be better understood by seeing a graph, because graph will give you a clear idea. I am showing this example to you to have better understanding of curvilinear correlation. Now here what I have done, I have taken students A, B, C, D, E, F, G, H, I, J. Instead of writing their name, I have given them A, B numbers like this. And then I have taken the marks in editing and marks in reporting. As a student of journalism, you know that we have two important papers. One is on editing and another is in reporting. Here I wanted to know whether there is any relationship between the marks a student gets in editing and marks he gets in second paper in reporting. Is there any association? Because people say if person is a good editor, then he will be good reporter also. So we wanted to check whether it is true or not true. So this you will see a student has got 20 marks in editing and 15 marks in reporting, and the student gets 25 marks in editing and 20 marks in reporting. Now you can go on seeing like that, but by seeing this data you cannot interpret. You cannot say that what type of correlation exists. So therefore what I have done is I have plotted it on the graph. On one side of the graph I have taken the students A, B, C, D, you can see in the graph very clearly, and on the other side I have taken their marks of series 1 and series 2. One is shown by the blue color, series 1 is by blue color and series 2 by red color. Now you will see the trend. When red line is increasing, blue is also increasing. It means there is a relationship. That means in that case of A, when he gets the marks in editing, he also gets marks in reporting, and both are increasing. If you go to in case of B, the ratio is different. It's going down. C, like that if you go on plotting marks, you will see two curves, two graphical lines, and from there you can very visibly say that the relationship between the marks received by the students in editing and reporting, there is relationship which is of curvilinear type. I cannot say whether it is positive or whether it is negative, but there is association of curvilinear type. This is the example of the curvilinear. In case of positive, it is very easy to understand. If age is increasing, literacy level is increasing, positive. If age is increasing and literacy level is decreasing, then it means one is positive and another is negative. So negative, one increases, second decreases. So there are basically, these are the three types of correlations we get when we analyze the data, when we are interested to find out association between the variables. There can be number of variables and we are interested to find out the correlation. Please remember that the measurement of correlation is very important for us to understand their relationship, whether two series are highly correlated, are less correlated, slightly correlated. We can find out by measuring their correlation. Otherwise, just by seeing data we can't find out whether it is highly correlated or slightly correlated, or no change is seen between opposite and the same directions between the two variables. So therefore, correlation measurement becomes very important. I will come to measurement of correlation little later. There are several methods of measuring the correlation. Here I would like to mention to you that correlation should be seen between the two sets of variables which are logically may be related or not related. Logically means, for example, if somebody says the coal production in the country is increasing, and then he will say population is also increasing, and let us see the relationship. Now, there is no relationship between the coal production and the relationship of the population, because population is another phenomena and coal production is another phenomena. So it will be absurd to find the correlation between two phenomena which are logically have no relationship. So therefore, we do not work out correlation between those variables which are logically not related. We work out correlation between those variables which are logically, from our point of view as a researcher's point of view, will have some correlations. Now that is what is very important, which has to be understood, that whenever you are interested in working out the correlation, measuring the relationship between the data, you must find out the logical reasons behind it and then start working and finding out the correlation between the various series. Now the question is that this relationship how to be calculated. In simple data, for example, I showed you a graph, and that graph I showed you the curvilinear relationship. So one method can be plotting on the graph. You can plot both the data and the graphs, attach them, connect them with the lines and see whether one is increasing, another decreasing, or one increasing, another is also increasing. That is a graphical method, but that is not possible in case of if your data is large enough. Let us say you have data of 300 people. Now, how to get such a big graph and how to draw it? So, graphical method might work for a smaller number of data, and it is easy to find it out. But this graph will not work when you have large data and you have number of variables. Then you will have to go for certain standardized methods of working out the correlations. So there are one method, as I told you, graphical method. Second method called mathematical methods. Through mathematical methods, we can measure the correlation. The famous method which was developed by Pearson, who is a mathematician, a great mathematician, Pearson, and is known as Pearson coefficient of correlation. He gave the formula and he went through the whole exercise of developing the coefficient of correlation. That is computed by, what he did, he computed it by the product of deviation from the arithmetic average, and divide that by the product of two standard deviation to the number of pairs in it. I will show you the formula, because in this the formula has to be remembered. There is no way out, and that formula has been evolved by Pearson, which is a very famous formula about it. Most of the people use this formula for mathematical calculation of the correlation of your variables. Another in this is concurrent deviation method. In this concurrent deviation method, what is that? If two series may be said as concurrent, if increase in one is followed by the increase in other, that is the positive correlation, or vice versa. Thus, simultaneous increase and decrease is occurring between the two series. That can be easily worked out. And now the graphical method I had already explained. Now we come to the Pearson coefficient of correlation. Now you will see is a big formula which has to be remembered by heart, or you have to note it down and keep it with you. Here I have shown the whole formula, and also I have depicted the name, for example, R is the coefficient of correlation. So R is equal to, you can see the whole formula, sigma dx, dy and all that. What is dx? Dx is the deviation of item values of X series from arithmetic average. Please remember, we use arithmetic average, means mean. There are median, mode, I discussed in the last series of last lecture. There are various types of averages, but we use arithmetic average because that is more correct and involve all the data. So what we first find out the arithmetic average, and then we find out the deviation from each item values. In one series, that is X series, and in second series, that is Y series, we again find out the deviation from the arithmetic average, because every series will have separate arithmetic average. And then we go on as written in the data, we work it out. Now the Pearson coefficient of correlation, in this the example is 10 members of adult and children viewers of TV programs are in a month. Find out if there is any correlation between the two, viewing of TV program by adult and children. So our problem is that I have taken a smaller example, that there are 10 adults and 10 children. Both of them watch TV programs, and this is for a month. Now we are interested whether the viewing of TV program by adult and TV viewing program by children, is there any relationship? Now the data is given, and let us see how we put it down. Now see this table very carefully. It will take some more time to understand, but let us see carefully so that we are able to understand properly. Now I have in the first column, I have put the adult viewers, and I have said X, and you will see adult viewers, their all data has been put there. Now second column is deviation from assumed average. So the average of adult viewers, which has been worked out by mathematical average, that is the mean, is 68. If you take 63, 64, 65, all these add up and divide by number of items, you will get the 68 as an average, arithmetic average. Now this has been taken out 68 deviation from each item, that is 68, 63 minus 68, 64 minus 68, 67 minus 68. So like that it comes minus 5, minus 4, minus 3, minus 1, and then 69 minus 68 plus 1. So this is the deviation from the arithmetic mean of that series. Then you square it up, that is D1 is square, deviation is squared up for calculation, so that minus and plus goes away. 5 becomes 25, 4 becomes 16, 3 becomes 9, like that. So minus plus situation is removed. Then we come to children viewer the same way. And then for children viewer also we have written the data like 65, 63, 63, 65, 67, 67. And then we have find out the arithmetic mean of it. And arithmetic mean for it is 67. How do you find out arithmetic mean? You total it up, 65, 63, 63, 65, all that, and divide the numbers of items. That becomes the arithmetic average, as we have done for adult viewers also. Here it came 67. So then the next step was how to then work out the difference, deviation from the arithmetic means. So 67 minus 65 minus 67, 63 minus 67, 65 minus 67, then you will see minus 2, minus 4, minus 4, minus 2, like that, plus 1 it again comes up. To remove the signs and for calculation purpose, we just square them up. So 2 becomes 4 and all that. Every column we go on adding. You will see the last column, last row is the add summation of the data which has been worked out. And in the last, what we do, we multiply the, what we multiply? We multiply dx and dy, that is deviation from the average in series 1, that is x, and deviation from the average in series y. Multiply both of them, that become dx into dy, and total it up. Now, how to work out the values? Sigma dx is minus 3 is the deviation from item values of the x series from its arithmetic average. You will see second column, which was deviation column of adult viewers, the total was minus 3. After you have worked out the deviation and then you add it up, it became minus 3. In the same way, deviation from the assumed average, in children, in case of children, it became minus 4. So that's what I have written. Sigma dx is minus 3 is the deviation of the item values of x series, and sigma dy is the minus 4, which again I have written from there. Then next I have written sigma dx and sigma dy. Now let's go to sigma dx and dy, which is the multiplication which has come out in your table. That is the 58. From where 58 has come? If you see the last column, total in the last is the 58. So this is the 58 which has come out, and the 75 is sigma dx square, which you will see from the third column of this table, which is the total of square of deviations. So please remember, this table is very important and the totals are very important. We take all the totals of different columns and rows for use it. Like that, we also work out sigma dy square, that is the total of the square of deviations. Now we put into the formula which I showed you earlier. You remember this formula which I showed you earlier? This was the formula. In this sigma dx dy we have worked out, sigma dx we have worked out, and we know, and all this sigma dx square we have worked out, and all this we put in this formula now. Here 58 we got the total there, 10 is the number. So you just go on putting and then start working on it mathematically. And now if you see, after working out each step, you get the result 0.85. What does it mean? Now when 0.85 is come, how do we interpret it? Our problem was 10 numbers of adult and 10 numbers of children viewers of TV program in a month. Find out if there is any correlation. Our result is 0.85. What does it mean? How do we interpret it? Now here I have written the interpretation. Correlation between adult and children viewers of TV program is of 0.85. It means there is a high degree of positive correlation between adult and children viewers of TV programs. Now how do I say it's a positive? Because if you remember, when I started my presentation, I said +1 is the perfect positive correlation and -1 is perfect negative correlation. It means as you move towards +1, you are getting positive correlation. As you move towards minus, you get the negative correlation. So the sign of plus and sign of minus indicates whether the correlation is positive or negative. Let me repeat, +1 and -1. +1 is the positive, perfect positive correlation. -1 is the perfect negative correlation. And tendency, if suppose you start on plus side, let's say 0.3, 0.5, 0.6, 0.7, 0.8, you are going positive side. If it is 0.3, is less positive. 0.5, you can say the middle level, so is positive. And if it is more than 0.5, then you will say highly positive. So in this case, the result came 0.85. That's why we are saying it is highly positive correlation between the viewers who are adult and between the viewers who are children. They are all watching TV programs and have the same tendency. That's what I said in the second para. Correlation is to be analyzed if it is high, low or moderate. So there are three types of correlations. in positive itself. It could be high, means nearer to +1. 8, 0.8, 0.9, 0.7 is high. It could be moderate if it is nearer to 0.5, 0.6, 0.4, 0.5, and it is low if it is nearer to 0.1. So it can be high, low or positive, low or moderate, positive correlation. In the same way, it could be high, moderate, low in case of negative correlation also. Now, this can be measured only by using Karl Pearson coefficient of correlation. Otherwise, it's very difficult to find out by using graphical methods. So here I have said the maximum degree of correlation, I said as I was saying 1, if correlation is less than 1/3, that is 0.33, then it is a low degree correlation. So you will have to remember, you divide 1 by 3, it becomes 0.33, then low degree correlation. If it is between 0.3 and 0.67, it is moderate, and if it is more than 0.67, then it becomes high degree correlation. Now these figures we can remember and always match the result, whatever results we get out of this. So this is called Pearson coefficient of correlation. I hope you are trying to understand this. It requires practice, and also it requires on your part to take your data, put them into table, work out the columns, and then work out the figures in terms of totals of each column, keep them ready and put them into the formula, and then mathematical process you start and reach to the result. You have to see whether you are going in plus, you have to check whether you are going in minus. If plus you are going, then you are going in positive correlation. If you are minus, negative correlation, and then the value which you are receiving, if it is less than 0.33, then it is low. If it is between 0.34 and 0.67, then it is moderate. If it is more than 0.67, that is 0.68, and up to 1, then it is highly positive. In the same way, if it is minus, negative it is coming, you can always say if it is less than 0.33, then low degree of negativism. If it is between 0.34 and 0.67, then it is moderate. It is more than 0.67, then it is highly negative. So remember these classifications, remember the formula, and remember how to calculate it, then you will be able to work it out. Now let us come to the nature of Karl Pearson coefficient of correlation, R. I have been always emphasizing R is always between plus and minus 1. Sometime I get the funny answer from the scholars that my correlation is 2.3. No, it can never be 2.3. It can never be more than 1. So it means you have done something wrong in calculation. It could be less than plus 1, it could be less than minus 1, but it cannot be more than that. So, R is always between plus 1 and minus 1. R can never be more than plus 1 in any case, and plus 1 is said to be perfect positive correlation, and minus 1 is said to be perfect negative correlation. And if the value you get 0, when there is a absolute lack of correlation. 0, what does 0 indicates? That there is no relationship, lack of correlation. And we don't find that value in case of communication research. In physical sciences, maybe chemistry, when there are two types of chemicals, you are trying to work on that, you might get 0, or you might get the perfect condition. Even the perfect is very less in case of communication research. Pearson method takes into consideration not only the direction of change of different pairs, but also the degree of such variation. Therefore, it is a more exact measurement than others. All over the world, Pearson coefficient of correlation is supposed to be the best method of working out the correlation. Why? Why is best? It is best because it takes into consideration all items of your data. As you must have seen while calculating it, that we took the viewers, adult viewers in one column, we took out the mathematical average of that column. It means all data was involved, because when you take out the arithmetic average, you have to add them and divide by the number, that is 10. So it means all data which was involved as adult viewer of TV programs has been taken into consideration, average was worked out, and then deviations were worked out from that average. Same thing was done for the children also. So it is considered as the best method because each item has been taken into consideration while working out the correlation. While graphical method, we are drawing lines from point to point, and it may not be exact because between the lines we have just connected them. But here each data is being considered separately. That's why it is supposed to be best. Now I come to the graphical method also, so that you should not have any confusion left. Now graphical method, as I was telling you, we plot both the series on a graph paper. I showed you in case of curvilinear relationship in correlation method. I can go back for your advantage to, yeah. Now you can see here. This is a graphical method. What is happening here? Here you have written on one axis an allotted space for each student. Student A, student B, student C, student D, F, G, H, I, J. We took so many students. So we have named them. On the other side, what we have taken the marks. And then first we plotted about the marks in editing. And marks in editing is shown in by the blue line. So we said A got 20 marks. So please see carefully. In case of A, the first dot is on 20. And in case of B, first dot is, if you see carefully, that is on 25. So like that you go on plotting. First you draw the first line, series 1, and then you plot the red one, series 2, that is marks in reporting. And then you get this picture, this whole curves. Now this is called graphical method of calculation. As I was mentioning to you, graphical method easier for if you have less number of data, maybe 10, 15, 20. Otherwise, the graph will become so big, it will be really tough to understand or work it out or plot on a graph. That would be a problem. So let's come to the graphical method. Now in graphical method, as I was explaining you, the values of two series are plotted on a graph paper. Please remember, that's what we have done, which I showed you in the graph. And then various points are joined by straight lines. The trend of two lines is now studied. That's what we study in curvy linear relationship, the blue and red line. Now come to the interpretation. If they move in the same direction with simultaneous peaks and troughs, the two series are said to be correlated. If the graph shows blue and red lines are moving ahead with the same height, same ratio, then we will say that this tendency is positive, because if one is increasing, another is also increasing. That becomes positive correlation. If both the lines are moving in the same direction and simultaneously going on, then it is good. If the one is going up and other is going down, then it is a negative correlation. One line is going up, and another line is going down and down. Maybe, for example, blue line is going up, and red line is going down. After plotting, you observe it. Then you will say negative correlation. There is no correlation. One is going up, another is going down. But if they are going in the same direction with the same speed, then you can say negatively correlated. So you have to work out by visual observation in graphical method what type of relationship exists, whether it is a negative, positive relationship between these two. And then only you can also work out whether it's a highly correlated, moderate correlated, or low correlated, just by observations. That is what I wanted to explain to you today about the relationship. Now there are certain complications in correlations. As I was mentioning to you, that the logical relationship must exist between the series of the data. If logical relationship does not exist, then it's absurd to work out the correlation. Wrong use of methodology for finding out the relationship between two series of data. I gave you the example of coal production and the increase in population. Coal is increasing, population is increasing. Then you will say there is a relationship exists between coal production and the population. You might apply this formula. You might get a result also, but it has got no meaning. For example, nowadays in our country it is being said that food production is going to be bumper this year. If we plot the food production of past 50 years, year-wise, and take the population growth year-wise, and then we will say if you take the correlation, correlation exists. Or it will be curvilinear correlation. Now that has got no meaning. How the food production, which is controlled by nature, controlled by certain other variables, population is controlled by certain other variables. These variables have no connection with each other, then how you can work out correlation between two series? You cannot work out the correlation. So that is one situation where logically, if data is not correlated, please don't work it out. You must see that these variables are series of variables on which you are working. This must have some relationship. Otherwise, it has got no meaning of working out the relationship between the series of the data. Here I gave you the examples in case of simple series. Now the question you may ask, if the series is not simple, it is grouped wise. For example, 1 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, like that, group wise. Then you will take the middle point of each, and then you will work out the deviations from the mean, arithmetic mean. Please remember, always deviation is to be measured or worked out by arithmetic mean, not by other means. Like, what are the other means? Other means are like mode, median, geometric mean, harmonic mean, progressive mean. We are not going to movable means, we are not going to consider them. Why are not we going to consider them? Because they are not based on each item of the series. We are not involving them in any mathematical analysis or calculation for the use of average. Only the arithmetic mean. We are using each item. How we are using each item? We take the item 1, 2, 3, 4, 5, add them up. Let's say in this series there are 200 items. So all the 200 are added and the total is divided by 200. Then the average comes out. It means in mathematical average you have taken the all those individual values into consideration and then you have worked out. In case of, let's say, if you use median. What is median? Median is the average obtained keeping in view the middle number of the series. And we say it is a, that's why it is called mean worked out by location. So we don't use those means which are worked out by location. We use only those means which are worked out by mathematical calculations in which each item is involved, so that your further analysis is also accurate. So don't commit the mistakes by using other than mathematical means, that is mode, median, geometric, harmonic, or progressive means and work out correlation. No, don't do that. You will reach to, you may reach to wrong conclusion. I am not saying definitely you will reach. No, you may reach to right conclusion, but we don't suggest at all. As a statistical experts, we say you please use only the arithmetic mean to find out the differences. Otherwise, your things may go wrong. So therefore, always remember that in statistics or in further analysis, we use always arithmetic mean. We don't use progressive mean, we don't use movable means, we don't use all of them in the interest of the calculation. So this is second point to be remembered. First was logical relationship. First you see whether there is a logical relationship or not. Second, you always use arithmetic mean. Third, when you are using graphical method for calculation of correlation, it's better only for visual presentation. What I mean to say visual presentation, you can see the red line, you can see the blue line going up, going down, visual presentation. But you never get the exact figure. While you are using the mathematical calculation method, you are getting the exact figure, 0.85. It means exact. But by visual, by seeing the graphics, you are not able to say definitely that the relationship which exists by numbers, exact you cannot represent. You can say I see it, I find by observation that there is a relationship exists between the two series of data. I can also say whether it's a positive or negative or no relationship, but I cannot say exactly that this type of relationship exists. So that is the biggest weakness in the graphical method, that you will not be able to say that. But advantage of graphical method, you can visually see it. While mathematical method, visually you can't see anything. It's only calculation, play of numbers, use of formula. So nothing is visually available. I have shown you both the things. There is a big formula, and then you have to calculate all the digits and then put into the formula, and then you go on working mathematically and reach to a certain number. So visually there is nothing. But in graphical method, you are visually seeing. You are seeing the blue line, you are seeing the red line, you are seeing how they are growing, how they are coming down. All that is visually possible. So please remember, you will take your own decision as a researcher. whether I should adopt graphical method or whether should I adopt mathematical method of analysis. If you are interested in visual perception, you want to show to the people about the relationship visually, then you use graphical method. If you are interested to get the exact numbers, exact associationship between the two series, then go for a mathematical formula. That's called Pearson formula, and you will go. So these are the two methods I have told you today, mathematical method and graphical method. I have told you about the classification of the correlation. I have also shown you the degree of the correlation, that is high, moderate, low. In both the cases you can always show. In graphical method also you can show high, moderate and low, and in mathematical calculation method also by number of point of results you can show that this is possible. So this helps us in understanding the relationship between two series of data, what type of relation exists. We can see visually, we can see mathematically, and we can say, well, this is relationship exists between these two series of data. That is what I think, if we have done it for all types of relationship, at least we will be able to make use of it. If you have any question, I know there are a lot of questions which will be coming up, because unless you do it yourself, practice yourself, calculate yourself by using this formula, you will never be confident. Of course, graphical method is very easy to do it. Most of you know about the graphical methods, you know about the graphs, and you can calculate it easily. But the difficulty arises, somebody
Yes,
says,
sir.
tell me one number
Yes, sir.
by which you can
Okay.
say this. This is not possible with graphical method. Then
So,
you will have to go to mathematical method.
Yes. Sir, thank you for the very informative lecture, a very well laid out lecture, and as sir has already recapitulated the points, so I need not do that, but I thank you all for being very ardent listeners. And for those of you who will be here watching tomorrow, our tomorrow's topic will be farm journalism. Sounds like a very interesting topic, so I hope you all will be tuned in to be here with Devesh sir, and he will be talking about the topic. And I thank you all, and I wish you all a very good day. Thank you.